In 8.2, we're going to be solving equations by factoring when a is not 1. So essentially, it was the same concept as 8.1, but now a is at any value besides 1. So if we have an equation in standard form, which is ax squared plus bx plus c, we're going to take a look at how we can factor when a is a number besides 1. And we'll need to, so let's say you need to find two factors of a times c whose sum is b. Let's go ahead and color code this. So I have my a and c, and I need to find two factors of the a times c whose sum is b. So I'm trying to figure out whose sum is b. And we can start this the same way that we started uh, the kind of the x method from 8.1. So up top we will do a times c. We'll put that product up there, and in the bottom we'll do the same as before where we put just the value of b, and then we try to find those two factors who equal the a times c, but when you add them together it equals b. So that doesn't change because before a was just 1. So we would say, okay, we'll just put the c up here. But now we're putting the product of a times c up here. And after we do that, we need to create a kind of a box model. So this would be the box method. Oops, that's not what I wanted to do. Okay. And let's see where these parts go. Okay, so in the top left, we're going to put our ax squared. And then in the bottom right, we're going to put our c. And then in the top right, we can call our nx, and then the bottom left are mx. And those are essentially those factors that we find from the x model. And then from there, we can factor it out and figure out how we can get the standard form into factored form. So it's better when we take a look at an example. So let's go ahead and do that now. We want to factor, call this example A, and let's factor 6x squared minus 21x minus 45. So as I approach this, I notice something. I notice that I can remove a 3 from each one of these terms. There's a factor of 3. And that's essentially what you want to do. You want to kind of simplify these three terms as much as possible to make it easier on yourself when you're factoring. Meaning I can remove a 3, and if I remove 3 from the 6, that becomes 2x squared. If I remove it from the minus 21, that becomes minus 7x. And if I remove the 3 from the 45, that becomes 15. So that's what you kind of need to do when you first approach a problem like this that has a value of a that's not 1. See if you can remove a factor first. So always kind of remove a factor first to make whatever's in this quantity a little bit more simplified. All right, so from here, let's go ahead and work on our the box method. So I'll start with the x method first, which leads into the box method. And as you can recall, I want to find the two factors of my a, or sorry, the product of my a and my c, which is negative 30. And I'll put in parentheses, maybe in yellow. This was 2 times negative 15. And then on the bottom of it, I want to put my b value, which is -7. And then I want to find two factors that when I multiply them, I get -30, and when I add them, I get -7. So this is the same thing that we did from 8.1. We're just, going through that process again. And I can tell that if I take -10 and I multiply that by 3, that gives me -30, and when I add it together, it gives me -7. And don't feel discouraged if you can't come up with them, right away. It does take some kind of, guessing and checking with your factors, but I'm just doing this just for the sake of time. Okay, so now what we want to do is let's work that box. So let me draw my box. Look at that. I was able to freehand a perfect box. Okay. And as you can recall, I want to put my the term with the a up here. So that's the 2x squared. And then I want to put the term with the c down here. That's -15. And all I did was take it from this quantity. I took my a, and then I took my c, and I placed them in that order. And it is important that you place it in that order. It's just going to, make it easier on you if you keep this kind of consistency. And now what I want to do is I want to take these two factors and place them in this box right here. So I'll put the 10 and I want to include x, and I'll explain why. And I want to put the 3 here and I want to include x. Because what's essentially going on, and I'm going to show you why you have to include the x, is I broke this down into factors of 2x squared minus 10x plus 3x minus 15. And as you can tell that this is the same equation, it's just this one is not simplified over here. I separated whatever the -7x was so that we can factor to, find our x-intercepts. So this is the reason why you have to include your x when in the box method. Okay. Let me erase these arrows. Actually, I'm going to need the space. All right. So now what I want to do is, find factors of each box where the top the top row and then the left column, they create the product within the box. So for example, I know that, let me do this in white, I know that to get x squared, it has to be x times x. But I also need a 2. So if I throw in a 2 here, I know that 2x times x gives me 2x. Okay, great. Now, there's already an x here, so I can't include an x up here because this is just x, it's not x squared. But what times x gives me 3x? Well, I know that 3 times x gives me 3x. So up here is my first factor. It ends up becoming 2x plus 3. Or I should say my first quantity. Now let's finish the one on the left side of the box. Okay, so there's 2x here, and there's already an x here, so I don't need to include an x, but what times 2x will give me -10x? And I know if I multiply that by -5, 2x times -5 does give me 10x, and checking the last column, 3 times -5 gives me -15. So this ends up being, and I'm just going to kind of show it this way, my second quantity, which in turn looks like this when we write it out. 2x plus 3 times the quantity of x, and I'm going to say not plus -5, I'm just going to put x minus 5. And that would be your factored form from this original standard form expression. Okay, let's do one more example. So again, the goal is I want to find a common factor to simplify these terms. Looking at this, it seems like there's a common factor of 5 that go in each one. So what I can do is factor out that 5, and that becomes 4x squared minus 8x minus 5. And again, I'm able to do that because 5 times 4x squared, whoops, 5 times 4x squared gives me 20x squared. 5 times negative 8x squared gives me negative 40x. And 5 times negative 5 gives me negative 25. So it's still the same expression. I just factored out the 5 for purposes of factoring. By the way, made one mistake going back to, I just caught that right now, example A. Notice that when we factored out the 3 up here, we must include it right here to finish off our expression. Okay, you have to include it, otherwise it won't be the same expression. Okay, so let's keep that in mind on this example. We got to keep that 5, throw that 5 in at the end. But for right now, let's factor within this quantity. And I'm going to start with the X method. I'm going to identify just my A and my C, and up top it goes, and I'm going to write this out, 4 times negative 5, and that gives me negative 20. Okay, so that's the one I'm looking at, the negative 20. And then at the bottom, I put my B, which is negative 8. And now I'm going to try to find two vectors of negative 20 whose sum equals negative 8. So you do want to play around with it. A lot of times it's great to start from, okay, it's negative 20 times 1, that gives me negative 20, but negative 20 plus 1 is negative 19. No, that doesn't work. What about, I know 2 times 10, okay, that's 20, so how do I get to negative 20? How about negative 2? If I do, and don't write this, but negative 2 times 10. And the problem with this is that negative 2 plus 10 gives me positive 8. So what I need to do here, whoops, start that over, is I need to switch the signs. It has to be positive 2 and negative 10 because 2 plus negative 10 gives me negative 8. We know 2 times negative 10 is negative 20. All right, so that gives me my M and N, my M and N. And now let me go ahead and start my, you don't mind if it's purple. The last one was white, but that's okay. Let's create the box method. And I'm going to put in my term with the A, which is the 4x squared, the term with the C. I got to keep the sign. Always make sure you put the negative 5. And now let's put my M and N. And it really doesn't matter if you put, say, negative 10x here and 2x here, or you switch them. It doesn't. Okay, so for example, if I wanted to switch this up, I could put 2x here and negative 10x here. You'll still end up with the correct quantities at the end. All right, so let's start from, I like to start from the first box, and I like to notice when I'm looking at these, a common factor. And there is a common factor of 2. So I'm going to assume that there's going to be a 2 out here because I have to get a multiple of 2 to get these products. And I already know that with this first one, this first box, there's an x squared. So I can assume that I can factor out an x and an x because x times x gives me x squared. Okay. And then 2x times x doesn't give me 4x squared, so I need to throw in another 2x. So 2x times 2x gives me 4x squared. Great. But notice that this is 2x and this is 2x. So what times 2x? So what times 2x will give me 2x? Well, anything times this number will give you itself, and that's 1. And that looks like this is our first quantity. And I'll throw a plus sign between that. Okay, coming down to this bottom row, I have this negative 10x. What times 2x gives me negative 10x is kind of similar from the last example. I know that's negative 5, and also notice that negative 5 times 1 gives me negative 5. So this ends up being my second quantity. And remember, we got to keep the 5, so I'm going to bring the 5 down. So I can draw an arrow here. Got to keep the 5, I'll circle it. And I can finish my quantity, and I can say 2x plus 1 times the quantity of 2x minus 5. I'm not going to set it equal to anything because the original expression, it didn't set it equal to anything. You didn't see any equal sign, so that's why it's just an expression. And this would be our factored expression. And it's nice, again, because we can find our x-intercept. I can set this quantity equal to 0 and solve for x, and set this quantity equal to 0 and solve for x, and I'm able to find my x-intercepts.